Okay, so we saw what a linked list is. We saw how the nodes or elements are defined in terms of struct. We saw head, tail, and all that. But why do we need a linked list in the first place when we have arrays which are much more convenient? So in an array, the elements are stored in continuous locations. So you don't need a pointer to go from 100 to 200, for example. Secondly, in an array you have indices, so you can access an element randomly by saying array of 5. So you don't need to go from element 0 to 1 to 2, 3, 4, 5. You don't need to do that linear journey to reach the fifth element. You can directly say array of 5. Both of that is not possible in a linked list. Then why do we use this data structure? So the thing is, what if you don't know the array length beforehand? So in C programming, when you're declaring an array, you have to declare a size, right? Int array of 5, 10, x, y, something. The size needs to be specified when you are declaring the array. In the real world applications, it is not necessary that you will always know the size of the array beforehand. That is one point. Secondly, what if your array size keeps changing through the course of the program? As in, I initially create an array with, let's say, 100 elements, and then I want to add some or remove some. For example, if I'm creating an array where I store the marks of all the students in my class, let's say there are 60 students initially, and then someone from the other section comes and joins this class, someone from this class quits and moves away. So the number is going to keep fluctuating. Not always, but there is the probability that the number or the array size might not be fixed, right? So if it is just one element, then you can have that extra element, that extra space, unused space, for example. It's not going to cause too much damage. But when you're working with huge quantities of data, you cannot arbitrarily assign array sizes when you do not know the size beforehand. So let's say I'm working with something like the Aadhaar card information of all the people in the country, and I cannot, and let's say I don't know the population, I'm going to randomly assign a number as the array size. So it is possible, first of all, that the number I assign is an underestimate, in which case if it is an array, I have to create a new array with the right size, and I have to again assign all the values one by one. That's a problem. Or if it is an overestimate, if it is a gross overestimate, a large amount of space is going waste. It is remaining empty, and space or memory in a computer is precious. So we cannot afford to take that risk by using arrays. So that's what this says. What if you don't know the array length, or if your program is such that the array size keeps changing? You keep adding or deleting elements. So what initial array size would you declare, and how many times will you reassign or create a new array? So a lot of time and resources would be wasted in such operations. So a linked list solves this problem by allowing the array size to grow dynamically. You don't need to know the number of elements beforehand. You keep creating or deleting nodes as necessary. So you will be seeing the operations in a linked list soon. And the thing is, at any given time, you are only going to create one node in a linked list, one node at a time. And then you will create another node and add it. If you don't want this node, you will delete it. So you do not need to know the array size beforehand. You can easily use malloc, realloc and free to increase or decrease the array size as required. So that dynamic memory problem, which arrays, which is a disadvantage in the case of arrays, that is solved by linked list. And while it might not be a big problem for small amounts of data, the larger your data sets, the costlier it is going to be, your memory space and computational resources. So that is where linked list becomes more effective over arrays. So to summarize, arrays offer benefits like indices and continuous memory, which linked list does not have. But in an array, you need to know the size beforehand, and if at all you want to change the size later, you have to create a new array and reassign everything, which is going to be a tedious task. In a linked list, you don't need to know the size beforehand. You can just keep creating nodes on the go and deleting them. And using malloc, realloc and free, you can allocate or clear space as you require. So in that sense, linked list is more efficient with respect to memory. which is why we prefer a linked list over an array, and which is why we are studying about this data structure in the first place.